Comet C-2220 F3 is getting a lot of attention because it was coming out of the deep freeze, so to speak. It hadn't been seen for several hundred years, and then all of a sudden here it was flying past Earth. And it was interesting because it had this sort of orangey color. It was big. It had a huge coma, and it looked like, well, it looked like a dirty snowball. So that got a lot of people's attention, and unfortunately, it fragmented. And that happens sometimes with comets when they get close to the sun. The heat from the sun causes the gases and dust to start boiling off the surface, and it loses its shape, and it falls apart. But that didn't happen right away. Well, now 4 years later, we are still seeing fragments of that comet, and they're just starting to disappear. So in this video, I want to go over what we've learned from studying this comet, and also talk about the James Webb Telescope and how it has helped us study this comet. Let's begin. Here's an image taken by the SOHO spacecraft in February of 2020 showing Comet C-2020 F3, which is actually made up of multiple fragments. Now, this comet first came around the Sun in 2018. It passed Earth at a distance of about 2.6 AU or 400 million kilometers. And then it went into the inner solar system, where it started getting closer to the Sun. And it had a pretty close encounter with Jupiter, passing within just 2 million kilometers of the planet. Then in early 2021, it passed Earth again. But this time it was only 1.4 AU or 215 million kilometers away. So that was a much closer approach than its previous pass. Now, after it passed Earth in 2021, it began to fall apart. You can see here that there is a main fragment, and there are many smaller fragments. Now, this fragmentation likely occurred between the two close encounters with the planet Jupiter. And why do I say that? Well, because there's another small fragment that is orbiting Jupiter, which means it was knocked off course by Jupiter during its close encounter with the planet. And although this comet hasn't been very active while it's been in the inner solar system, meaning it hasn't produced much gas and dust, it did produce a bolide event, which is basically a bright fireball in the sky. On June 29, 2021, there was a bright green bolide seen above Siberia, Russia, and it was determined that the fragment that broke apart and caused this bolide was about 5 meters wide, and it exploded in the atmosphere at a speed of 170,000 kilometers per hour and at an altitude of about 80 kilometers. But why was this comet orangey and not white like most other comets we've seen? Well, scientists think that the reason for this is that the dust that makes up the coma, or the fuzzy part of the comet, is actually absorbing sunlight and re-emitting it in the red part of the spectrum. Scientists think that this happens because the dust contains complex organic molecules that have conjugated pi bonding systems. Basically, there's these chains of alternating single and double bonds, and electrons can move freely between them. And because of this, it causes the dust particles to be very good at absorbing ultraviolet light and re-emitting it in the visible part of the spectrum, hence the orangey color. Now, scientists were able to study the composition of this comet before it arrived in the inner solar system. When I say scientists, I really mean one guy. His name is David Jewett, and he's a professor of planetary science at UCLA. And he and his students were able to analyze the comet remotely using a 300-foot telescope in Hawaii. And they discovered that the ratio of carbon dioxide to water is 7:1. Now, carbon dioxide ice is black, and water ice is white. So they concluded that the orange color of the comet is due to the presence of a lot of carbon dioxide. But why does this comet have so much carbon dioxide? Well, it formed far out in the outer solar system, where it was cold enough for the CO2 to remain frozen. But as it moved closer to the sun, the heat from the sun caused the CO2 to sublimate or turn directly from a solid into a gas. And that created the coma. Now, remember, this is just for the coma. The actual nucleus, or the solid part of the comet, is still way out there in the Kuiper Belt, and it hasn't started breaking apart yet. But there is some evidence that this comet may have been destroyed already, but it will take hundreds of years to find out because its fragments are moving very slowly. They have very low velocities, and so even though they're spread out right now, Eventually, gravity from the planets will pull them in and they'll begin to coalesce, meaning they'll smash into each other and stick together. And hopefully we'll be around to see that. I want to talk now about the James Webb Telescope and how it has helped us study this comet. Now, the James Webb Space Telescope, of course, is designed to observe things outside of our solar system, things like stars, galaxies, and planets that are orbiting other stars. But every once in a while, it takes a break from that and observes something in our own solar system. And that's just what happened with Comet C 2020. Scientists asked NASA to point the James Webb Telescope at Comet C 2020 in March of 2023 and again in April of 2023, and they were able to get some amazing data. Here's an image taken by the James Webb Telescope in mid-April showing the comet and its coma. You see, the James Webb Telescope takes images in infrared light, which is invisible to humans. So in order to see the image, it had to be translated into wavelengths of light that we can see, which are red, green, and blue. And the colors that you see here, they represent different temperatures. The warmer parts of the comet are yellow and orange, and the colder parts are blue. So this shows that the coma is not perfectly spherical, and that tells us that there are jets of gas and dust coming out of the comet at those locations. And that helps scientists understand the activity level of the comet and how it's evolving over time. Another thing that's interesting is that the James Webb Telescope can look down into the coma and actually see the surface of the nucleus. In this image, you can see that it looks like there's a lot of activity going on, lots of different features that are changing from day to day. And obviously, the resolution of this telescope is much higher than any other telescope we've used to observe comets. Not only that, but it can also look in the mid-infrared. And this shows us things that are warmer than what we can see in the regular infrared. You can just see the nucleus, and it looks like there are some active areas right here where there's jets of material coming out. And that's important because it gives us clues as to what might cause the outbursts or the jets of material coming out of the comet. There's actually two possibilities. One is that it could be caused by heat from the sun, causing the surface of the comet to boil. Or it could be caused by the release of gas inside of the comet. Either way, these jets are definitely helping to propel the comet through space. We know that because scientists have measured the change in velocity of the comet as these jets have been firing. And that's probably what will eventually break apart the rest of the nucleus and send it hurtling towards the sun. And if you want to learn more about what the James Webb Telescope is doing in our solar system and also outside of our solar system. So what will happen to Comet C 2020? Well, it will continue to orbit the sun until 2026, when it passes Earth at a distance of 1.2 AU or 180 million kilometers. And then it will start its journey back out into the outer solar system. Now, it's possible that by then it won't be a single object anymore, but a swarm of smaller comets. And that would be an amazing sight to see. Thank you very much for watching. I hope you enjoyed this video. If you did, please give it a like and subscribe if you haven't already. And I will see you next time, and as always, keep looking up.